Example number 5. Find the area of the largest rectangle that can be inscribed in a semicircle of radius r. So we have a semicircle, and let's choose the circle so that the circle has a center at 0. So we have this is y and this is x. So assume that this is a rectangle. We may have another rectangle like this also, right? Okay. So you notice that the radius r of the circle does not change, so it is a constant. So now let's just look at the rectangle in the black color. So we have this is x and this part is y. So this have to be another x also, right? So we know that the area of the rectangle is the length times the width. So the length in this case is x and x. So that would be 2x and times y, the width. So we have 2xy. We know that we have the circle equation is x plus x squared plus y squared equal to r squared. So we will solve for one variable. So I'm going to pick y, and y will be r squared minus x squared. Then we plug into the area formula, so we will get 2x times square root of r squared minus x squared. This is the function of x. Because again, r squared is a constant, so the x between 0 and r. So the x is the length of a rectangle, so cannot be negative. So we will take the first derivative of the area. So you're gonna work on this more detail. So I'm gonna do it short. We use product rule, right? Okay, so we will get this, and then we find the least common denominator, which is r squared minus x squared. So you will multiply the top, the first one, by r squared, square root of r squared minus x squared, and then simplify. Then this is you will get. Okay. So to find the critical point, we will set the a prime of x equal to 0. That is mean that the top have to be 0. Because the bottom cannot be, the r square have to be bigger than or equal to x squared. The maximum, the axis maximum is r, so the bottom cannot be 0. So we just set up the top is 0. Okay, so we get 0 right here. That means 2x squared equal to r squared. Then x equal r divided by square root of 2. Now we have 3x value, 0, r, and this. Actually, you can find the x value where the a prime does not exist. That means x have to be equal to r. So now we plug in 3 values. So 0, 8 of r over square root of 2, and 8 of r. So when you plug in 0, we're gonna plug into the function a, the area function. So we get 0, and if r equal to 0, if x equal to r, then 8 also 0. So we will have 2 r over square root of 2 times r squared minus r squared divided by 2. Simplify this, we get r squared. So what does it mean is that the max area is r squared. So r squared is the max area. Okay, so we have the other way to solve for this problem using the trigonometry. Okay, we don't have to use calculus to do that. So let's draw the circle units, semicircle again. And also we have y here and x here. Okay, so let's assume that this is the angle theta, and we have a rectangle like this. Okay, so this is the r, right? And we have the x. The x is here, and we have the y is here. Okay, so what is the x comma y coordinate? So x is r cosine theta, and y is r sine theta. So the a theta is equal to, because we have another x. Okay, so we have 2 of the x, right? So 2 of the x times y, that is 2r cosine theta times r sine theta. And we got 2r squared cosine theta sine theta. But we learned from trigonometry that is 2 sine square, 2 sine theta cosine theta is sine of 2 theta. Okay, so you know that the sine function for any angle theta is between -1 and 1. So the maximum value of sine of theta is 1, then a is max, right? It's max value. So it's happen when the sine of 2 theta is 1. So sine of 2 theta is 1. That means 2 theta have to be pi over 2. That means theta will be pi over 4. Okay, so anyway, the max value of the area is r squared, and we get the same as we using the calculus to solve.